Hello, my name is Krista, and with today's video, I'd like to show how people can construct M20 millimeter snoot with pitch 1 millimeter with fine thread and bore 19 millimeters. Okay, before I do something, the constructions, I'd like to explain you how I have added this formula here. Okay. Now we have an internal thread. Internal thread we construct like this here. First, I have a H. I have explained in the, but I'm doing again. This measurement here, from here to here, is the H, you see. Okay? And this measurement from here to here is the P divided by 2. Okay, so now H divided by P divided by 2 is this formula equal tangent 60. H divided by P divided by 2 is the tangent from this, and this is the 60. 60 is the 90 minus 30 is the 60. This is the 90 degree, this is the 30, and this is the 60. So H divided by P divided by 2 is the tangent for 60. H from here is this P divided by 2 going here, and multiplied by the square root from 3 is the, if we will write mathematically, is the square root from 3 divided by 2 multiplied by P. Okay? And this one is this here. Okay, now we have this length from here to here, but we have a H divided by 8 too. So this is on the 5, H divided by 8 is this one, plus this length, which is H divided by 8, is this formula. So now it's very easy. 5 plus 1 is the 6, multiplied by H, and H is the square root divided by 2. And this measurement is the, I will change, this will be 1. So this measurement is not correct. So I will take my calculator. So I will calculate this one, and this one will be 6 multiplied by square root from 3 multiplied by 1, and 8 multiplied by 2. Okay. And this one will be, just a moment, 6, 16, I'm sorry, 6, 3, 8, 2, enter. Okay, is the 0, 0, 6, 50, 49 and 50, 650. Okay, and I'm going out now. Okay, and this pitch will be, I must change this one too. It is 1 divided by 8. Is the 125. Uh, 1 divided by 8 is the 0, 125. I'm going out. So this measurement now is, so okay, I can explain this. P divided by 8 is this one, this measurement here, this length, and gives this result. Okay. I hope that you understand this one. It's very easy. So you can do a couple of times so you can understand what is the differences between the internal and external thread. This one does the differences is this length here and this length here. So you can try to do some exercise you should understand. It's very easy. Okay. Now we start to do our part design, and we could call that node M20, and we can write pitch 1 millimeters. We can write length of, okay, that's not necessary. Okay. Now we have everything. So now I take this plane and hit the sketch. I take this circle here. Okay. So, and this one is 20 millimeters, the diameter. Okay. I'm going out. So now I must open, sorry, this picture here, PDF file, I'm sorry. We have a 20, and the SW we will construct. I'm sorry. We go back. No, I'm a cycle. Okay. This is not 30 millimeters. I'm sorry. I will change that. Okay. And I will take the polygon here. This is the polygon. Okay. I take this one here, 6. I take one center line. So this is the vertical. Double click dimension here. And this one, coincidence. Okay. Now, let me see what is the border here. Border is the 90 millimeters. So this one, this measurement is the 90 millimeters. I'm sorry. So 90 millimeters. Now, V is the 30. So I take this measurement here and this measurement, and this is 30 millimeters. What is the 30 millimeter? 30 millimeter is this one here. So this measurement must be the 30 millimeters if you like to working with this net. Okay, now everything is okay. So now I'm going out. Okay, so now I will take the pad here. Just click pad. Okay. And H here is the 15.5. We should change that 15.5. Control one more time. Okay. So now it's finished. But I think I will do that here like this. I will divide that with 2. So and I will take the mirror. So this distance from here to here is the 15. This distance from here to here is the 15, and this the I'm sorry. This distance from here to here is the 15.5. So if you divide this one is this measurement, we take okay here. So why I did that? I did that because I'd like to mirror this one now. I can do so. Just hit this plane. This is the front plane, and I take the sketch, and then now take this line one time, so, and so. Dimension. Take this here. Okay. So now we will change this one. And this one is the 30 divided by 2. We should take coincidence here. Okay. So now we'll take the angle too. The angle is the 30 degree. Enter. We don't need to do some dimension here. It doesn't matter. I can take this dimension. I can take another dimension. For example, this measurement from here. We will take something, or I can take another dimension by doing hit this one and this one. Sorry, this one and a right click. You can take coincidence is the same. It doesn't matter. I'm doing now. I just doing like this. So you mark this one and take the mirror, and they're coming another side. So you go out, and you take the groover. So you take this one. Okay. So now I have the same like this one here. Okay. So now is the time to apply the thread. Okay. So I'm taking now the first one. I must have a point first, and in Z direction, this point will be okay. Here I don't carry. I'm taking in Z direction. I'm writing 30, and X direction. No. Okay, I can take X direction. I can take X direction. Doesn't matter. X direction is the 19 divided by 2. This diameter, because this the border is the 19 millimeters. 30 is, I take in 15, for example, preview is the, I take 10, preview, it's okay. So now I hit this plane here. First, before I'm doing that, I'd like to do a chamfer here. Take chamfer. For this is the 1 millimeters. In this, okay. So you have a chamfer. because chamfer we need it. Okay, so now I'm going to start mechanical design, wireframe, and surface design. Hit this one. And if you can find, you should click here to find this measure. Maybe sometimes can be this one, but you can take the helix here. After that, you take this point, and you take H and pitch. Pitch is the one. And now you need to take the axis, and axis is the z-axis. I think this one is little. I will take 25. Preview, they are going up. The reverse direction is the vary. I'm taking 20. It's okay. So now is the time to sketch the cutting element. Cutting tools, for example, I'm sorry. We take sketch. Okay. So now we will take one time like this. So can I see if this is close? Yes, it is. Now I will take here 60 degree. I will take 60 degree on other side too. Okay, now I'm upright. So now I'm going here to take a 3 tangent circle. 1, 2, 3. It's okay. Now I mark this one and hold down the control key, this one, and right click and go down and take construct element. Okay. Now you see that this one and this one is not in coincidence. I take one dimension here and here, right click and take coincidence. So now we are in the right position. This is very important. Okay. So now I must apply dimension here. This is, I'd like to control if I did right. It's okay. Okay, so this dimension now here, from here to here is 0,650. Okay, enter. And this dimension here, I will do that now. Take a line here. Okay, and this line will be the same construct element. So first you hit, right click, and take the construct element or geometric element is the same. Now, dimension, and this dimension is 0,125. Okay. Now, you go here, and take the 3 points arc. You take this point, and then you take out here somewhere. I must cut this one here. So, or trim. Now I will take this with this line here, right click and take tangency. So now everything is a tangent. We take one line here first, from here to here, another line from here to here. So control is everything is okay. You go to the sketch analysis and you see that everything is closed. The dimension control one more time if the dimension is okay. 0.65, 0.65, 0.125, everything is okay. So now just you go, and here is the tangent, this one. So everything's okay. I'm going out. Okay, so now you right click here in the part design, define the work view. I'd like to change this one and take the properties and I write here nut M20 millimeters pitch is the 1 millimeters. Enter. So I have a change of this one here. Okay, so now this one is the in define object. I will start mechanical design, part design. I hit the slot. First this one, second the helix. I will change this one pulling direction. I will take this line here, click OK. So now we've done. You see the thread is beautiful. Now we'd like to apply the materials. We're going here, apply materials. We take metals, we go to the steel, we mark the nut, apply materials. Okay. Now we double click here and we come in the properties. We just take this one here. So you can take what do you want? What do you think is good for you? I'm taking because this is setting. Okay. So now I can play with this here, with this function here. I can do how I can think that this will be. You can play. So apply. Okay. So our nut now it's finished. So if we see that if it's the same, so you can just play in here, double click, and you can do how do you like. Maybe you can take another, for example, if you like to take, you can take this one, for example. Okay. So you can play with that. So thank you very much. I hope that you enjoyed this video. If you think that is good, you can subscribe. You can give the comments. See you later. I will do that in the PETAC Creo parametric. I'd like to show to the people how can you construct bolts and nuts. Thank you very much. Goodbye.